A library has many identical shelves. All the shelves are full, and the number of books on each shelf in a certain section are summarized by the following stem and leaf diagram. Let's read the key. 3/6 represents 36 books. So that would mean 7/5 means there's a particular shelf that has 75 books in it. Okay. Find the number of shelves in this section of the library. Okay, for that you add all these up because these are four shelves. The first one has 33 books, then 36 books, then 39 books, then again 39 books. You need to count the total number of shelves. So this has four data values. Second one has two data values. All of these are mentioned here. All you need to do is add them up, and I believe it gives 67. Okay. Draw a box and whisker plot to represent the data. Okay, so in a box and whisker plot, we need the lower quartile, then, sorry, the lowest data value, which is 33. Then the lower quartile, we'll calculate it in a second. Then median, oops, it's not supposed to squeeze like that. Then the upper quartile, okay, this looks really bad. Okay, and median has a line like this, and then in the end we need the highest data value, which is 99. Now we also need the lower quartile, median, and upper quartile. Let's start with the median. So there are total 67 data values. We do 67 plus 1 divided by 2, that gives us 34. 34th shelf is the median shelf. So let's see where 34 is. So that's 4, then 2, then 4, then 20. What is the sum of those? That's 30. So 31, 32, 33, 34. So 73 is the median. Next is the lower quartile. How do we find the lower quartile? Count the number of values towards the left of the median. These would be how many data values? 4 plus 2 plus 4 plus 20 plus 3. That's 33 data values. Now what's in the middle? We do 33 plus 1 divided by 2. That's 17. So the 17th shelf is the lower quartile. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 64. So lower quartile is 64. And upper quartile will be count 17 from the end. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 90. Upper quartile is 90. Now we're going to take an appropriate scale here. On the x-axis, we need to go from 33 to 99. So maybe we could start from 30. So 30, 40, 50, 60, 70. Oh my God, it's completely overlapping the next part. Let me try to do a better job at it. Okay, so I've scaled the x-axis and now we label it. So these are the number of books. So you write number of books. Okay, so lowest value is 33. 33 would be 1.5 box ahead of 30. Then we have 64. For that, we can go one box, 2 boxes ahead of 60. Somewhere over here. Then It's 73, so 1.5 box ahead of 70. Okay, then 90 is right here. Then we need 99, so half box before 100. Join these with vertical lines. Okay, this is the box and whisker plot. Okay. In another section, all the shelves are full and the number of books on each shelf are summarized by the following stem and leaf diagram. There are fewer books in this section than in the previous section. We can see that if you count these, this will definitely be less than 67. What are we getting? 13 plus 15 plus 8. So yeah, there are only 36 shelves here. Okay. So there are fewer books in this section than in the previous section. Okay. State one other difference between the books in this section and the books in the previous section. Okay, so that comment could be that in this new section, the books are actually thicker in size. Why do we say that? Because look at this. There are 49 books in this particular shelves, and it says that the shelves are full. So 49 books makes the shelf full, whereas here, if we read this one, 99 books make the shelf full. So that means these books are thicker in size. So that could be your second comment. The following are the maximum daily wind speed in kilometers per hour for the first 2 weeks in April of two towns, Bronla and Rogate. Draw back-to-back stem and leaf diagram to represent this information. Okay, so we need a stem in the middle and one city on one side and the other city on the other side. So which city should I take on the left? I'm going to take Bronla on the left and Rogate on the right. Bronlia and Rogate. Okay, now I need to decide on what goes in the stem. The lowest values are one-digit number like 7, 5, 4. And then we have some numbers in tens range, then 20s range, and then 30s range. So I'm going to write 0, 1, 2, and 3. The very smallest value for Rogate is 4. So I'm going to write 4 first. Okay. Next is 5. So, oh, why isn't it writing? Yeah, then 5. Then we have 6 and 8. Sorry, then we have 7 and 7 again. We have two 7s. Sorry, I was looking at some other question. 7 and 7. Okay, next in the tens range, we have a 10. So I'm going to write a 0 here. This reads as a 10. Okay, then we have 11. So a 1. Then 13, so a 3. Then a 15, so a 5. Then 16, so a 6. And then 18, so an 8. In the 20s range, I have 23 twice, so 3 and 3, and then 26, so 6. And then in 30s, we have 34 only, and that's it. Okay, do the same for Bronlela. The lowest value is 3, so 0, 3. Then we have 0, 6 as well, so 6. Then we have 13, 14, and 17. So 3, 4, 7. Then we have 21, 22, 24, 25, 27, and 28. And then we have 32, 33, and then we also have 45. Okay. Now we need to give a key. You must make a key. Key is, I'm going to write this, 1/2/3 represents 23 kilometer per hour wind speed for Rogate and 21 kilometer per hour wind speed for Bronella, Bronlia. Okay, key is done. Write down the median and the maximum wind speed for Bronlia and find the interquartile range for Rogate. Okay, we need the median for Bronlia, so we need to find the value in the middle. There are how many data values here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There are 14 data values. To get to the middle, we do 14 plus 1 divided by 2. That gives us 7.5. 7.5 means you need to take average of the 7th value and the 8th value. So what's the 7th value? 1, 2, 3, 4, 5, 6, 7. 7th value is 22 and the 8th value is 24. That means the median would be their average, which is 23. So the median is going to be 23 kilometer per hour. And find the interquartile range for Rogate. Okay, so for interquartile range, you must first locate the median. So again, these are the same number of data values. So there were 14 data values. And then we again need to look for the average of the 7th and the 8th value because first we're identifying the median. So 1, 2, 3, 4, 5, 6, 7. This is the 7th value. This is the 8th value. So the median is actually 14. Okay. Now we need to look for the upper quartile and lower quartile. Look at all the data values at the upper end of the median. How many are these? 1, 2, 3, 4, 5, 6, 7. There are 7 values. So we have a 4, we have a 5, we have a 7, another 7, a 0, a 1, and 3. So what's in their middle? This 7, this 7. So 7 is the lower quartile, 0, 7. And similarly, to find the upper quartile, this is the 4th value from the start. Now we look at the 4th value from the end. 1, 2, 3, 4, which is this. So upper quartile is 23. So 23 minus 7 would be 16. 16 would be the interquartile range for Rogate. Okay. Use your diagram to make one comparison between the maximum wind speed in the two towns. Now we could either compare the medians for both of the towns or the interquartile range. Interquartile range will be more time consuming because we will have to calculate it for Bronlia. Instead, we already have the median speed for both of them. For one of them, it came out to be, what was that, 23? And for the other one, it came out to be, we got 14. So for this one, it came out to be 14 kilometer per hour. So the comparison would be that on average, Bronlia has greater wind speed as indicated by higher median. Following are the annual amount of money spent on clothes to the nearest $10 for 27 people. Construct a stem and leaf diagram for this data. Okay, I'm just going to copy it from the marking scheme and then we're going to discuss it. Okay, so the data is already in ascending order. So that is convenient. So the stems start from 0, then 1, 2, 3, 4, and 5. It says 1/4 means $140, so 140. That means 3/1 would mean $310. So 2/5 would mean $250. 1/4 would mean $140. And 0/6 would mean $080, so $80. So that's how they've made the stem and leaf. Remember to write the key as well. Okay, so let's consider part one to be done. Part two, find the median and interquartile range for the data. Okay, so we have 27 data values. What's valued in the middle, that will be the median. So for that, you do 27 plus 1 divided by 2, 14th value. Let's look at the 14th value. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is the 14th value. So median is going to be $160. Yeah. And now we need the interquartile range. For that, we need the lower quartile first. For lower quartile, look at these data values before the median or at the upper side of the median. These are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 in number. So their middle value would be 13 plus 1 divided by 2, the value on the 7th position from 13 plus 1 divided by 2. Okay. Seventh position has 1, 2, 3, 4, 5, 6, 7. This value, which is 140. So up lower quartile is $140. Similarly, for upper quartile, you could further move another 7 positions from here or even from the end. So 1, 2, 3, 4, 5, 6, 7, that's this number. Even if you come in reverse, you get the same value. Yeah, so the upper quartile would be 210. So interquartile range would be upper quartile minus lower quartile, that is 70. Okay. Next part says find an outlier is defined as any data value which is more than 1.5 times the interquartile range above the upper quartile or more than 1.5 times the interquartile range below the lower quartile. List the outliers. Okay, so the outliers are the abnormally large values or abnormally small values relative to all the other values in the data. So we do see quite a few outliers, like maybe 570, 450, are the outliers, and maybe 10 and 40 are also outliers because they're like either extremely high or extremely low. But how are we certain whether these are outliers or not? They've given you a formula. So first multiply 1.5 with the interquartile range, which was 70, which gives us 1.5 times 70 is 105. Now get the upper quartile, which was 210, and add 105 to it. That gives us 315. So any value above that would be the outlier. So that would be 450 and 570. Similarly, what you do, you subtract this 210, the product of 1.5 and 70, from the lower quartile. Lower quartile was 140 minus 105, that gives us a 35. So we also have another value which is less than 35, which is 10. So these three values would be the outliers.